Hi everybody. Today I'm going to talk about multi-period binomial option replication. Multi-period binomial option, I guess, pricing replication. So what do I mean by this? So I guess we've gone over how to price an option according to the binomial model for stocks, where it goes up or down and then it keeps going up or down like this. Or it can only move either up or down, and only two possibilities. So we found out how to price this, but we haven't actually gone into specifics for how we should actually replicate this. Like if I wanted to replicate the payout for a multi-period binomial option, how would I do so? I think to start off the discussion, it's interesting to note that, as we know, right, if we just take a look at this, for example, tiny period between t equals 0 and t equals 1, the way we found out how to replicate this option is by solving a linear system of equations and then choosing x and y that replicate the option payout, where x is basically units of stock, units of S0 to buy, and y is the dollars in cash account, right? However, for example, if we get to this spot, so let's say the stock has gone up, and now we need to price this part of the option. This is sort of a different system of equations, right? And it has a different solution set. So this will have an x, let's say x1 and y1, which will be different from the x and y. Sorry, why did I draw that there? It'll be different from the x and y here. Because it's a different system of equations. So this one would solve the us0x plus, ry is, and then if this is cu, then cu, and then dsox plus ry is cd, if cd is here. But now if we're here, then this possibility is u squared s0. So this equation will look totally different. And this one is, this one is just S0, so there will be no D here. And this payout as well will be different, right? Because this is a different value from these ones. So what I'm trying to say is that as soon as a new period, as soon as you roll over into a new period for this multi-period binomial model, you have to recalibrate, reshuffle your portfolio if you hope to continue to replicate the option payouts. In order to produce a replicating portfolio. So this is known as dynamic replication, and it's dynamic because like I said, we have to keep rebalancing how much money we have in our, how much stock we own, and how many units of the cash account we've bought. So let me introduce a couple pieces of notation. Here we have ST. ST is, as we know, the price of the underlying stock. Underlying at time t, right? So now in addition, we're introducing BT, which is the price of the underlying cash account. What I mean by this is at time t. What I mean by this is because of discounting, right? The cash account value sort of goes up. So BT, namely, in this multi-period binomial model, is equal to r to the t. So because of discounting, money that you put into the cash account is worth more in one period. And if you want to borrow, then it also costs more to borrow. So the cash account will cost more. So the dollars today will be worth less tomorrow, which is why this sort of the price of this cash account keeps going up. Hopefully that makes sense. So then I'll also introduce XT. So what is XT? XT is the number of shares that you hold between t minus 1 and t. Notice it's t minus 1, so it's the previous, okay? And then YT is the number of cash account units you hold also between t minus 1 and t. So let me draw you a picture So here we have S0, okay? And we decide to, and then let me just also say, so theta of t is just the tuple x, y, xt, and yt, and it identifies what our strategy is, what our current strategy is, right? How many units of shares, how many number of shares we own, and how many units of the cash account we own. So here we are at S0, we have theta 0, theta 1 is x1 and y1, okay? So this x1 and y1 will be the number of shares that we hold between t equals 0 and t equals 1. So here we have at S1, so here's the number line. And so in this entire time, okay, we keep holding, we've made a decision at t equals 0, and we stick to it for the entire period, because that's our only choice in this binomial period model. We've chosen to, again, this is our choice, x1, y1, and we hold this until S1. And as soon as S1 starts, we have to reevaluate again, because the solution to the sort of the risk neutral probabilities and the solution to replicating the option payout is different now, and the solution is different. So now we have to sort of choose a new x2, y2 to replicate the new option payout that depends on S1. Okay, so again, we started at 0, we've chosen x1, y1, and we sort of hold some units of the stock and some units of the cash account. And the only thing that's changing between here and here is the price of the underlying. Okay, so this could go up or down, right? And then after that, we have to recalibrate. Hopefully that makes sense. Okay, so let's add a new definition also. So VT, or the value of the replicating portfolio, is equal to ST multiplied by XT plus BT multiplied by YT. So self-explanatory, right? It's the current value of the portfolio. Okay, of portfolio. So it's we have a value here, and then we have a value here, and then so notice, for example, V1 is equal to S1 X1. So this is V1 is still referencing the shares that we bought last period. And as soon as this new period starts, when we choose the new X2 and Y2, then this V changes, or possibly changes, if we've made some changes. So let's get into that. So suppose we have V1 here, and then immediately after, we look at S1 X2 plus V1, or at least very close to, and then Y2. Okay. So what does this mean? So as soon as we start, like I said, as soon as we start the new period, we have to rebalance our portfolio in order to achieve new option payouts. So we've created a new X2 and Y2. And then I'm also going to introduce a new definition, which is called, let me check, I forgot the name of the definition. It's called self-financing, a self-financing portfolio. Here we go. Self-financing portfolio. So as I suggested, right when we roll into this new period, we have to choose a new X2 and Y2 to replicate the new option payout. And it would be nice, right, if this new, this is the value of our portfolio starting right after. It would be nice if this new V didn't change, if all we had to do was rebalance it, if that makes sense. So it would be nice if VT, so here's the definition of a self-financing portfolio, is equal to ST XT plus 1, okay, plus BT YT plus 1, okay. So this would be nice, because that means that our new portfolio was created entirely from the ashes of the old one. So there's no new cash added, right? And the point of going over all this self-financing portfolio is because we expect and we think that the value of this portfolio, right, I think according to our option pricing theory, should be exactly equal to the price of the option, right? So, and the price of the option, the stock goes up and down, the price of the option changes, but the point is there shouldn't be any need to like inject any new sort of cash, and then the price when we reach this new stage of the portfolio, or the value of it, should not change either, right? It should mirror the option price, right? So then there's, I guess, a theorem. So if we have a self-financing portfolio, then VT plus 1 minus VT is equal to the following. So this will be ST plus 1 minus ST, XT plus 1 plus BT plus 1 minus BT multiplied by, YT. Okay. When I looked at this, I was thinking, oh, you could just stack them together. What if you did VT minus 2 minus VT, and then this will be VT minus 2 minus VT plus 2, VT plus 1 plus VT plus 1 minus VT, and then but it doesn't work out because these XTs you won't be able to cancel out, is what I'm saying. So there's no way to like collapse everything in, even though I would have liked that. So anyway, how do we prove this? It's very straightforward. So for the VT plus 1, right, we use the definition of the self-financing portfolio, which we have here, which is immediately on the start of this new turn, right, the value is still, so proof, the value hasn't changed, right? So for this one, we use the original definition. So VT plus 1, it's ST, XT, again, plus 1 plus BT plus 1, YT plus 1, okay? And then we're subtracting VT. So minus ST, XT, and here we use the new definition, minus BT, YT plus 1. And then we can collect it and get the answer directly. So what is the point of this theorem? The point of this theorem is, I guess, to understand just intuitively what the difference in the value like of the portfolios is, of this sort of self-financing option replicating portfolio. What has happened? So XT, I guess we've decided this. So basically, it's only dependent, I guess, VT plus 1. I guess if we look at the timeline here, I'm getting slightly confused as well. So here we have T, and then here we have T plus 1. Okay, yeah. So the XT plus 1 is this, right? So here's our XT plus 1, and then YT plus 1. Remember, it's the previous period, right? So basically, the difference in the values is only equal to the difference between it's only dependent on, I mean, this we've decided here at the beginning here, how much X and how much Y to own. So basically, the difference in the values is only dependent on the difference between the stock price and the difference between the cash account price, right? And it's not dependent on the point of self-financing portfolios. We haven't injected anything into it. That's sort of, I guess, it helps understand what changes an option, the price of an option, right? And it's these two factors, right? If we assume that our self-financing option replicating portfolio is represents the fair value of an option, which I think it does. Okay. Finally, I think there's like one topic that I missed, which is how to price American put options. So as we know, sometimes it's, unlike call options, sometimes it's useful to exercise early put options, which is why when you are using the binomial model to calculate the prices of the put options, let's say it goes like this. Sometimes, like for example here, you might actually need to do a check to see whether it's more useful to actually exercise a put option rather than continue on. So this will be a max between the price of the option as determined by this, right? By the whatever this Q 1 over R times Q times if this is CU plus 1 minus Q times CD. So there, and at the same time, ST, so minus the strike price, right? Or this, yeah, this payout, right? Let's just call it CV. There. So, yeah. So basically, what I'm trying to say is, unlike call options, we also need to add this like extra special case here where we're also checking. And I actually try to use the example that he gave with numbers, and I wasn't able to replicate a time when it was better to exercise it than to keep going based on the current value of the call option. So maybe it depends on like specific values of UND and R, but at least I based on his example, like I couldn't. I was getting that this one is bigger, so than you would get by just exercising it. Okay, thank you so much. See you next time.